Hello everybody and welcome to this video. Today, this video should be a very simple video, just looking at some introductory topics to aerodynamics. Hopefully by now, if you're watching this video, you should already be familiar with these three different states of matter: solids, liquids, and gases, and you should know how we can tell them apart by their behavior. So imagine we have an empty container for each of them. If you put a solid in an empty container, it maintains its shape and its volume. If you put a liquid in a container, it maintains its volume, but its shape will change to fit the container. And if you put a gas in a container, well, its shape will change and its volume will change to expand and fill the space of the container. So all this you should already know. But what you might not already know is the difference between fluids and non-fluids. You might already know that liquids and gases are fluids, and solids are not fluids. But what determines what's a fluid and what's not? And the answer is quite simple. Just like the three states of matter, fluids and non-fluids are defined by their behavior. But instead of their behavior in a container, we look at their behavior when shear stress is applied to them. So here you have a solid, and if I apply stress to the side of this solid, a few things might happen. One, it might resist the stress, or two, perhaps there'll be the slightest bit of deformation. But generally, this deformation or this change in shape will stop as soon as we stop applying the stress. This is different, however, for fluids. If I have a fluid and I was somehow able to apply a sideways stress to it, what you're more likely to see is this ripple effect, where the fluid will keep moving in all sorts of weird and amazing ways, even after you stop applying the shear stress. This is the same for both liquids and gases. If I start blowing a gas one way and then stop, the gas will keep moving in different ways. There'll be convection, there'll be fluid flow, and that's the difference between fluids and non-fluids. So fluid dynamics is the study of how fluids move. And of course, fluids include both liquids and gases, which can be studied independently because gases are also able to expand and change their volume. And aerodynamics, which is what this book focuses on, is just the study of how air moves. Now, most of the knowledge that we have on aerodynamics originated from the study of fluid dynamics. Some of the earliest works on fluid dynamics was done by Isaac Newton when he published his famous Principia. Back in his time, a good understanding of fluid dynamics could help countries have better navies and win wars. His work was continued by other scientists in the Age of Enlightenment, such as Euler and D'Alembert, and it was mostly used just to study liquids until around 1901, when the Wright brothers were experimenting with airfoils and airflow to create their airplanes. Now, this book makes the distinction between two very different but very important applications of aerodynamics. The first is external aerodynamics, which is used to predict the different forces and moments on bodies that are moving through a fluid, usually air. Meanwhile, internal aerodynamics looks at how air moves through different solids, whether that be pipes or wind tunnels or certain types of engines for engineering. Both of these applications of aerodynamics will be discussed in this book, and I look forward to going through these topics in future videos.